Okay, this is an introduction for the motion graph lab, and what we'll be taking a look at are the position, velocity, and acceleration versus time graphs and how they relate to one another. So we'll go ahead and pop open the simulation, and what I want you to do is I want you to sketch what you think the graphs will look like and explain your reasoning. Then what I want you to do is go back and correct your reasoning, or go ahead and correct the graphs after you've gone ahead and done that. So let's go ahead and do this very quickly here. So if you can draw on it, great. If you have to print it out and draw on it, fine. But go ahead and pick yourself a color, and I'm going to draw my velocity versus time. So it's going to be -1. And what I know is I know that the acceleration is going to be the change in velocity over the change in time, or better yet, if you've seen calculus, it's the derivative of the velocity over dt, so it's the slope. I don't know about you all, but the slope of this thing is going to be 0. So I'm going to put a big fat 0 right here. What I can then do is I can say, okay, let's take a look at the position versus time graph. What's going to happen is I'm probably going to be sitting at some position, and I can just call that 0, why not? And what I can do is I can say I know that the area under this curve is going to be increasing over time, and also in the negative direction. Something that I know is that the position is going to be the integral of the velocity graph. The reason why I know that is because the velocity is going to be the change in position over the change in time, or if you've seen calculus, dx dt. So what I can do is I can kind of draw this thing increasing, and I know it's going to be linear. If your prediction is wrong, I don't care. All I care about is that you go ahead and make a prediction, and in fact, I would be very suspicious if all of your predictions were right, and then the very last thing that you do is wrong. So just kind of throwing that out there. So let's go ahead and do that really quickly. So what I can do is I can go ahead and pop back over to the moving man simulation. I'm going to go to the charts. I'm going to set his velocity to -1, and I'm going to hit play. And what I kind of see is something that looks more or less the way that I thought. Well, up until he hits the wall, but that's going to, be different. We can zoom in on these guys. So for example, if I were to zoom in on this, you can see that the velocity is indeed -1. And if you want a really good, kind of look at it, I hid the velocity graph. I meant to hide the position and hide the acceleration. So what you can then do is you can go back and correct your thing. So if you made a mistake, well, then you go back through and correct the color. It does say explain your reasoning, so I am looking for text right there. And again, if you go ahead and you just put your text into it, then please do make the color slightly different. So if you do this, then please do something like that. Then what we're going to do is we're going to kind of come back here, and we're going to give him a velocity that is now positive. And then after 5 seconds, I have you change the velocity to 0 and press enter. So sketch what you think these graphs will look like. Then I'm going to have you set the position to -1 and give a velocity of constant +1. Same deal. Then I'm going to have you do a position of -1 and then a constant acceleration, be careful here, of +1 and press play. As you're paying attention to these graphs, what I want you to be paying attention to are the graphs curving? Are they positive? Are they negative? Are they constant? Are they 0? So I have you do a couple more scenarios with a negative acceleration, and then I have you do this one and then change it. Then last but not least, I have you take a look at this and write out a scenario and draw the position, velocity, and acceleration graphs for this particular scenario.